Okay. Talk about compound interest. Let's do a couple of simple calculations, okay? Let's say you have $1,000. $10% annual interest in that. That interest is compounded annually. So let's just see. Well, I want to know how much you have after 1 year and after 2 years. You could calculate that for me. Just to make sure you understand, and get something wrong, we'll fix it. So that was a simple idea, and then we can set it up so it's more algebraically accessible. Okay, but the simple idea is small there. Interest is 10% of $1,000, right? And 10% of $1,000 is $100. So we have $1,000 plus $100, which is $1,100. After the first year. And so for the second year. Interest is ten percent of 1,100 is 110. Okay. And of course, we need to know how to take 10% of any number. We do this like multiplying by 0.1, it just means we can move the decimal over one place. Alternatively, we just divide by 10. It's 10%. What does percent mean? It means per 100. So 10 per 100 is 1 per 10. Okay. 10 hundredths is 1/10. Meaning divide by 10, or if you like, multiply by 0.1. Okay. We have $1,210. After the second year. Okay. Now we're gonna set this up algebraically and express everything algebraically, but let's first see how much we have at the end of 1 year. If we split that 10% up. So I'm going to give you 5% at the end of 6 months. And then 5% of whatever you have at that point at the end of the year. So what we're doing is we're compounding. Twice annually. Okay, so I just wrote down what I said. We had 5%. Then again, 5% of what we now have at the end of the year. Now I should be able to calculate 5% of 1,000. But then calculating 5% of that result, you're probably going to want to use your calculator. Okay. So I believe. But got it. I would say the final result of some of the numbers going to be added. Okay, so let's just do it. Okay, so. I'll say after half a year, instead of 6 months, because like, if we wanted to compound it 10 times. Okay, we'd have to say after 1/10 of a year, after 2/10 of a year, and so forth. Because 1/10 of a year doesn't have a name. Okay, it's after 36 days. We usually say there are 360 days a year, but it's 36.5 days. Anyhow, so I'm going to say after half a year instead of after 6 months. So after half a year. So we'll earn $50. Okay. Now, if we understand that 10% of 1,000 is 100, then it makes just perfect sense that 5% of 1,000 being 50. Okay. And of course, 5% means 0.05 times. We can easily multiply 1,000 by 0.05. And since it's a nice round number, we shouldn't have to use a calculator, but it's okay to use a calculator. Back it up after we figure it out. Okay. Then we earn 5% of $1,050. Okay. And 5% of 1,050. Well, 5% of 1,050. 5% of 50 is $2.50. Things we have. We earn $52.50. So we have 1,050. We have $1,102.50. We agree? Okay. Well, if we want to predict what we have after 30 years, compounding twice a year, we don't do 60 calculations. We'd inevitably almost certainly screw it up. Of course, we could always use it. So, whatever, and calculate it, but it turns out we can calculate it by fairly simple reasoning. So I want to go with that simple reasoning. First of all, let's just go back to 10% annually. I'm trying to make it. Okay. I'm not going to do the calculations. Okay. I'm going to do year 0, 1, 2, 3, and so forth. I'm debating about how much to shortcut this. I'm going to make the observation that $1,000. I'll just do change the dollar. 1,000 plus 10% of 1,000 equals. What do I get if I factor out 1,000? If I factor 1,000 out of that expression? What do I have? See if we can write that down. Okay, now this is a little hard for people to see. We often get 1,000 times 0.1. Okay, because it's 1,000 times 0.1, but of course, if we use the distributive law, just 1,000 times 0.10, we don't get 1,000 times 0.10 times 1,000. All we get is 1,000 times 0.10. So we know that can't be right. That thing that's hiding there is if we factor 1,000 out, whatever we get here by the distributive law has to equal this, because the distributive law is just a backwards. I mean, the factoring is just a backwards application of the distributive law in this case. Ultimately, that's all that ever is. Okay. So, leave it at that. Okay, it's got to be 1,000 times 1 plus 0.10, because now if we multiply it out, we get this. And so if we factor, remember, we always then do the multiplication, make sure we have what we started with. And if we do that, then eventually we're going to see the 1, and that's exactly what we saw here. After I did have that 1,000 times 0.10 without the 1. When it was pointed out, all of a sudden, I saw that finger go up, and I knew that that was correct. Okay, so it's 1,000 times 0.10. And of course, what's another way to write 1 plus 0.10? So you just do the addition. Okay, so write down what we get there. Have to record it. Yeah, exactly. Okay. And I knew you'd get that right away. Okay, so we have 1,000 times 1.10. And that equals 1,100, doesn't it? Okay. Now, How can we calculate 1100 plus 0.10 times 1100 with just a single multiplication? Okay, now we saw this very quickly, very nicely, and everybody just wrote down 1,000 times 1100 times 1.10. Well, first we factor. Then we get this. And if we multiply that out, we get our 1,200. Well, we can go on then. We could very quickly do this. First, probably use a calculator to multiply. This wouldn't be that hard to do it using multiplication algorithm. There's no real need. Because eventually these numbers just get to where we just it'd be crazy to do all the arithmetic by hand. Okay, that's about as far as we probably want to go do the arithmetic manually or by hand. Okay. And it's not that difficult to do this manually. We get $121 interest. Okay. 121 added to 1210 gives us 1331. But after that, again, eventually we lose it. Now, if you know the binomial theorem, then you can go a lot further with it. Used to be a standard topic. Now, it's not necessarily our advantage, it no longer is, but that's a different story. Okay. Now, what do we see here? What do these calculations have in common? Well, what they have in common is you've always got that 1.10, no matter what number you add 10% to, you multiply it by 1.10. Okay, so now we can say that adding % is the same multiplying by 1.10. Or as I'm going to write it out by 1 plus 0.10. So we can make a table in year 0. In other words, when we first start, we have $1,000. At the end of year 0, we have $1,000 times 1 plus 0.10. And of course, you can calculate that, but I don't want to calculate it. I want to get a general formula, how much we have after n years. Okay, so I'm sure I left myself enough room here. Spacing. Up to So after year one, we have $1,000. On 1+.10. Now, depending what I see people doing. There are many ways I can set up this table, okay? But no matter how I set it up, kind of didn't leave myself enough room. Okay, so, still, now how much will you then have without doing any multiplications or anything, just in terms of the expressions that we have? What would you write down for the expression we have at the end of the second year? Okay, it's a little tricky. So I'm having a little bit of trouble with this. I'm gonna write it down. I'm gonna say we have 1,000. Times 1+.10, because that's what we have at the beginning of this year, right? Now, how do we get the amount at the end of the year? We multiply by 1.10. We multiply the amount at the beginning of the year by 1+.10. Now, what we had at the beginning of the year was this. So whatever our expression is, what we have at the beginning of the year, we're going to multiply that by 1+.10. Make sense? Okay. Okay, that's great. Okay. Well, now, can you fill out the year two, Robert? All right, well, that was good. We got a good expression for what we have in the second year. Now, there's a problem with this because what we got has to be written pretty small because it's getting pretty long. I think you know what I've written here. I've just written this 1,000 times 1+.10 times 1+.10. I actually have some parentheses around this. And of course, this is the same as this was. And part of parentheses is just what we have at the beginning of the year, and then we multiply by 1+.10. You know, it's even more fun if we get the result at the end of this year, which would be 1,000 times 1+.10 times 1+.10 times 1+.10. Now, this is untenable because we want to go out in 1,000 years. Okay, now we're getting very close to being able to calculate this for 1,000 years. You might see it already. Since I gave you the hint, we can write these a lot shorter. We just use exponents. Now, it's not going to be obvious to everybody, but unsurprisingly, it was obvious to everybody here. Okay, so I'm going to erase what I originally wrote here and write it all with exponents. First of all, here, I've multiplied by 1.10, and then I've multiplied by 1.10. That means I've multiplied by 1.10 twice, which means I can write this amount as 1,000 times 1+.10 squared. Okay. And then I'll write this one out as 1,000 times 1+.10 squared. But then that's times 1+.10. Because again, every year I'm adding 10%, which is just like multiplying by 1+.10 or 1.10, as we saw here. And if you calculate this, well, okay, let's go ahead and write it down. Okay, this is at the end of the second year, which is, of course, the beginning of the third year. at the beginning of the third year, then I'm gonna have this much, but I'm gonna write this out as 1,000 times 1 plus 0.10 cubed. Because the square times pi gives us the cube. That's 1,000. Okay. Now, if you put these calculations into the calculator, and if you're going to calculate it, you'd actually just multiply. You wouldn't have a plus, and you just multiply by 1.10. I've got the plus there for reasons we're going to understand very shortly. Okay, but if you do these calculations on your calculator, you're going to end up with 1,100 here, same as we have here, 1,210 here, and 1,331 here. And at this point, I like to use N for the year, but a formula that we're working to understand, whether you understand that we're working to understand the formula, and go ahead and try to digest that statement. Uses N differently. N is the number of times you compound. But I don't want to use N for the number of years, so I'll just use T. Because years represent, years measure time. So after T years, well, what would you write here? Okay, we got an interesting response, which is very insightful. Okay, the response we got was this. Okay. And then I said, okay, now let's go. They said, well, that's the end of the year. Yeah, that's what go here. But what happened? What do we have at the beginning of the year? It would just be T because, well, think about it. In year one, how many times have we multiplied by 1.10? Once. For year two, we multiply again. We have twice, okay? And then year three, we've done it 3 times. After year T, it'll be T times. Now, the insight was, yeah, we knew that was for the end of the year. So the only remote error in that was the +1. Because again, I don't know what everybody's doing, but you're thinking. That was a good thought. It doesn't quite match up with the pattern, so we go ahead and correct that. Although I really like that answer. It's this. Now, I was going to go on and write out the expression for the end of the year, and that would be writing it out completely, the amount at the beginning of the year times 1 plus 0.10. I was treating that as 1T 0.10 because now I've got T's in there. And that looked a little strange to me, so I had to think for a second. Okay, so that's 1,000. Times 1 plus 0.10 to the T plus 1. Now, we've actually just got a little aside here. Okay. Mathematical induction. Ever heard of mathematical induction? Probably not. Although I probably didn't hear of it in my algebra classes, probably in my trigonometry, and well, I had a year of trigonometry, and then I had a year of essentially logic. Okay. I think that's what it was. It's probably semester. From trigonometry to semester of logic. Or combined course. Okay, well, the logic is, think about this now. Okay, I know that multiplying by 1.10 gives me the result at the end of 1 year. And of course, I can build up a pattern here. And it's useful to do that, okay? And the pattern is so obvious that I really don't require a lot of proof here. But when mathematics gets a little bit harder, you do want to be able to prove things. Okay. So the proof is, well, okay, the first step. The formula 1 plus 0.1 over the t works. Because t equals 1, and you get exactly what you expect to get. So we can prove that. Okay. Now we prove that if we know it for, if the formula is right for t years, then it's going to be right for t plus 1 years. Well, that's all we've got to do because t could be any number. And that means this formula goes on to infinity. Okay. Now we never get to infinity, you know, we don't get all that close because we don't live that long. Okay. We get to do this for 100 years, starting in our teens, and we'll have a pretty long life, unusually long. Okay. Now, let's think about what happens if we let's just develop a formula for this. If the interest rate is R, then here's our formula, P equals P sub 0, where P sub 0 is taking the place of our 1,000, it's whatever number we start with, times 1 plus R raised to the T. In this formula, gives the amount for annual compounding, and I could have written that a little more specifically, but I didn't have room. Didn't leave myself. I'm the one who creates the reading here, so I'll take the blame. And I'm gonna write this the way I intended. I'm going to write this as P of t. It's a function. How much you have after time t is a function of your interest rate and how much you started with. Okay, now given how much you started with in the interest rate, it's a function of time t. Well, that's good. Now I think we're probably in a position to understand what happens if we compound twice. So now we're going to do 1,000. At 10%. We're going to compound twice annually. So our years will go 0, 1/2, 1, 1.5, 2, and so on. Our amount starts out at 1,000. Our period is half a year. So we want the amount at the end of the period. So let's see if you can write out the first step and maybe the second. And maybe even a little more than that, but if you can write out the first year, I'm happy. Or first 6 months, write out the 6 months, I'm very happy. And you see the whole pattern, I'm ecstatic. Okay, so let's write this out carefully. At the end of our first period, we have $1,000 times 1 plus 0.05. Okay. Now, that's the amount we're gonna have after half the year. We're not gonna multiply that out, we're just gonna multiply, write this as 1,000 times 1 plus 0.05. Okay. Now, what do we have at the end of this period? Well, at the end of every period, we're gonna get the amount at the end of every period by multiplying by 1 plus 0.05, because every period we're adding 5%. And the period is half a year. Okay, so we're gonna have 1,000. I'm gonna write this a little bit small. Thousand times. Yes. Talk is misbehaved. That would be a big deal. I looked myself up. Okay. Okay, so at the end of the first period, we got 1,000 times 1.05, 1 plus 0.05. And then we have to take that amount and multiply it by 1 plus 0.05 to get the amount at the end of this period. Now, using exponents, this is just $1,000 times 1 plus 0.05 squared, right? So now what do we have at the end of this period? Yep, and then we can write that with exponents when we write it down here. So go ahead and write the next amount and hopefully the next one. Write a couple more lines and think about what you're writing. Then we'll See if we can establish the pattern. Okay, so what do you think it's going to be after T here? Okay, that's good, except it doesn't quite fit the pattern. What if you substitute T equals 3? What do you get here? You get this? We have to do an order yet. I didn't even have to ask. That was very good. Okay. So, really think about what you're doing and test it. Okay, thank you for the reminders and recording. I think lose this. Okay, that was very good, very good. Okay, so we were able to write up several more steps of this. Okay, because every time we go half a year, we multiply by 1 plus 0.05. So we would have, well, here would be 1,000 times 1 plus 0.05 squared times 1 plus 0.05. And that is just 1,000 times 1 plus 0.05 cubed. And at this point, we really don't have to write out this column anymore. If we go to another year or another half year, we're going to multiply by 1.0 plus 1 plus 0.05 another time. And that'll be 1 plus 0.05 to the 4th power. Now, if we go to 2 years, and there's a little glitch when I asked if we to write this out. What I got at first was 1,000 times 1 plus 0.05 raised to the T power. Okay. But then I posed the question, and Maybe I guess you want to think about the question. Does this formula work when T equals 2? Well, if T equals 2, you get 1,000 times 1 plus 0.05 to the second power. But when T equals 2, should be the fourth. When T equals 2, if you use this formula, you only get this. It costs yourself a lot of money over a period of many years. And well, I said that, and then like lightning, I saw hands go down here. Oh yeah, gotta put a 2 in front of that too. Okay. So writing it out just a little more neatly. We have a formula. Thousand times 1 plus 0.05 to the 2T. So now here's a perfectly good formula. We're going to do another thing to it. If our interest rate is 10%. The 5% is half that interest rate. So our function is T naught times 1 plus 0.10 over 2 to the 2T. Why is the 0.10 divided by 2? Because we're compounding twice annually, right? Why do we have a 2 times T? Because we're compounding twice annually. We're compounding twice every year, and T is the number of years. So the total number of times we multiply by this is twice per year, 2 times T. Okay, so if the interest rate wasn't 10%, if it was 8%, well, it's obvious, I think, what we would do. We'd take 8% and divide by 2, right? So we're going to say that this is 1 plus R over 2 to the 2T. R is our annual rate. Now we've got 2 minutes. Let's see if you can get this in 2 minutes. We'll go on this next time. But let's see where we are. Okay. We compound n times annually at rate R for T years. What's our P of T function? Okay, so we came up with a very good expression that kind of is modeled in this from P of T equals T naught times 1 plus R over M to the T. And that's good, except that we compound more than T times in T years. In 1 year, you're going to compound n times. 2 years, it'll be 2 times that. 3 years, it'll be 3, and 12 years, it'll be 12 then. Well, in T years, it's gonna be N times T. Okay, just like here. We had to put a 2 in front of T because we're compounding it twice every year. Whatever number of compounds, we're compounding 10 times in a year, it would be 10T, wouldn't it? If we're compounding N times a year, it gets a little harder to think about abstractly. But we're gonna have to compound it NT times in 2 years. Okay? So. What it comes down to, each period, what we're adding is R over M, we're adding interest R over M, okay? And in 2 years, that'll be done NT times. Now, my strategy in writing this out, make sure we understand that I wanted to write the multiplier as 1 plus 0.10 here, because that mimics what we're going to get from our ultimate formula, okay? And the 1 plus 0.05, same thing. We want to think in terms of 1 plus 0.05, not 1.05, because we can't write 1 point R over M. Okay, we'll understand why we have a plus R over M. So make sure we understand why we have the R over N and why we have the NT. Okay. And then we'll do a little bit more next time. And ultimately, it might be interesting to see where E comes from out of this. Okay. E being arguably the most powerful number in all of mathematics.